Hi, year 10s. Okay, we're going to talk about conduction of electricity. We've looked at metallic bonding, and we also looked at giant covalent. We looked at graphite, and graphite and metals have these things called delocalized electrons. The electrons are kind of just thrown away, and they don't have a place or a locale of their own. They're not stuck. They can move. They're said to be delocalized electrons. Because they've got charged species that can move, that means they can conduct electricity. And we've got a very nice simple setup here, Queenie, if you can just move back and show. We've got here a power pack, it's connected to a light bulb, and it's going, what we're going to do is just complete the circuit. And this is a 6-volt bulb, so we hope we're not going to blow it up, because we're running at 6 volts here. And we should know that one of the best conductors of electricity is copper. Of course, we use it in wires. So what happens if I connect the circuit, look, here, and we should see the light bulb go on. Yay! Because metals can conduct electricity, and they can do that because they've got delocalized electrons. What does that mean? What is actually going on here? Well, we have a power pack. This is the negative electrode, and this is the positive electrode, okay? So electrons are negative, okay? So the electrons are running through the wire towards, and the delocalized electrons in here are moving towards the anode and completing the circuit, because the electrons can move throughout the structure here because they're delocalized. It can conduct electricity. Now, we also know that graphite has a similar setup. So let's try and see now, does graphite conduct electricity? Let's now use the same setup again, and we should see, I hope, yep, the light bulb goes on again. Look, as I connect it together, I can't quite get this clip to go right over the graphite, but you can see here, I'm not cheating. It's the graphite. If I remove it, look, oh, hello, it's gone off. If I put it back on again, and the bulb's not quite as bright. Graphite's not quite as good a conductor as electricity as copper, but clearly graphite conducts electricity as well. Okay, what if we now compared that to something that doesn't have delocalized electrons? Something like sulfur. I've got some yellow sulfur here, okay? And sulfur here is a simple covalent structure, okay? Actually consists of molecules of sulfur. If you do A-level, you'll find out they actually have 8 around them. But if I connect this together, so this consists of S8 molecules, it's simple molecular, there's no conduction of electricity. Because sulfur doesn't conduct electricity. And the reason why it doesn't is because it doesn't have any delocalized electrons, and it doesn't have anything charged that can move. In the next video though, we're going to see there's one other structural type that can conduct electricity. So just to repeat then, things with delocalized electrons can conduct electricity, just finally to make the point here, because they've got electrons that can move through the structure. Whereas if we compared that to a covalent structure, simple covalent, there are no electrons now that can move, right, and therefore it doesn't conduct electricity. But what other substances conduct? We're going to come back and watch a video on that in a second.